Hello everyone, I am Ayoti Banerjee, Assistant Professor, Department of Geology, Durgapur Government College, and today I will brief you all I will give you a brief introduction about remote sensing and its application. Now what is remote sensing? Remote sensing is a technology in which we obtain information about some feature or phenomena through analysis of data obtained from a device which preferably we call sensor, and that device is not in physical contact with the feature or phenomenon we are recording within the area of interest. So the term not in physical contact is the essence of remote sensing. Now, how to capture information about a place or area of interest without being in physical contact with it? It happens through a remote sensing system. In a remote sensing system, there are certain elements. First, we need an active or a passive source of energy. That in this case is sun. Why sun is a passive source of energy? Because we do not on or off the energy coming from sun according to our wish. Sun is always present, the earth is rotating. That's why certain parts is getting a night time, certain parts is getting a daytime. But the energy from sun is always present. So the energy incoming of sun's energy is not in our hand. But because that energy is coming from sun, the electromagnetic radiation that is coming from sun is falling at the target, and then from the target it is going to sensor. And this is happening by the virtue of the energy that is always present. Therefore, it is a passive source. And what is an active source of energy for remote sensing? When, suppose in case of synthetic aperture radar, there the radiation, we send the radiation through to the object of interest, and that illuminates the target and comes back, reflects back, and we catch it in our sensor. So when we, the human beings, are designing a particular source and we are sending the signal through that source, we are calling that kind of remote sensing as active remote sensing. And because the sun is always present, therefore it is a passive source of remote. It is a passive source, and the remote sensing we are doing by using the sun's energy is called the passive remote sensing. And then the sun is illuminating the target, the sun is sending the signal is an electromagnetic radiation, and the target is reflecting it back. Some it is absorbing, of course, and some is scattered and some is reflected back. Out of that reflected back, which reaches the sensor, is captured by the sensor or the satellite, and these satellites are of different kinds based on the need, what is the application of that data. Suppose we want daily data or a data of 24/7 or over an area, so we will design a satellite that rotates along with the speed of the earth in that particular area, over that particular area, so that 24/7 the sensor can capture data. But certain sensors are not like that. They also revolve around the earth and visit the same place after a certain period of time. So based on our need, the sensors or the satellites are designed, and then after the sensor captures the data, we transmit back the data to the earth, and the data is stored in different formats, and we use the stored data for analysis and application. We do a pre and post processing of the data, and then we go for the analysis. Now the best part is suppose we are doing a passive remote sensing, the entire electromagnetic radiation that is emitted from the source does not reach the target, because some of the radiation is absorbed by the atmosphere, some of the radiation is scattered by the different particles that are present in the atmosphere, some of them are scattered by the clouds in the atmosphere. Only a part of it reaches the target, and the part that reaches the target reaches in the form of an electromagnetic radiation which is composed of both alternating magnetic fields and electric fields that are at 90 degrees to each other, and that part that reaches the target is absorbed by the target. Some are scattered because the target has a different kind of irregular shape, it's not a smooth reflector always, and some of them are reflected back. And the part that is reflected back, out of that, some are absorbed again by the atmosphere when it tries to travel through it, some are scattered by the atmosphere, and only a part of it reaches the sensor. The part that is absorbed by the target is later emitted by the target in form of certain radiation, which we will see next. Now, what is an electromagnetic radiation? It is an energy which is propagated in the form of an advancing interaction between electric and magnetic field, and it travels with the speed of light. Now, this is the electromagnetic spectrum. Here it starts with ultraviolet and ranges till far infrared. Now, there are two kinds of remote sensing that happens. One is visible and near infrared remote sensing. So, the incoming radiation and the outgoing radiation, when lies from ultraviolet to the mid-infrared, we call it the solar radiation part, and that comes under visible and near infrared remote sensing. But as we already discussed, there is a part that is absorbed by the target and then it's emitted later. That emitted part actually falls, that energy is emitted in the range of mid-infrared to far infrared, and that is the terrestrial radiation emitted by the land and the water surface, and that comes under thermal infrared remote sensing, this part of the electromagnetic spectrum. Also, the electromagnetic radiation actually follows this simple principle of frequency of the radiation into the wavelength of the radiation that equals the velocity of the radiation. Because the velocity is 3 into 10 to the power 8 meter per second, and we can see that the higher the wavelength, lower the frequency, and the lower the wavelength, higher the frequency. The frequency and wavelength has an inverse relation. So if we know the wavelength of a particular radiation, incoming or outgoing, we can easily find out the frequency because the velocity we know is 3 into 10 to the power 8 meter per second. Now, what are the advantages of remote sensing? Why remote sensing is gaining such popularity among different disciplines? First, it's a non-contact mode of data capture. Non-contact means, suppose there is a cyclone that is happening and we want to capture its path. We want to trace the eye of the cyclone and we want to calculate what path it will take and on how many days it will make the landfall. In that case, it will be very unsafe for us to go to the place near the landfall to observe it or go in the sea to observe its pathway. So obviously, in such risky scenarios, we will want the non-contact type of data capture. And now, because of technological advancements, at the weathering, sitting at the weather monitoring stations only, we can actually we can capture remote sensing images of the sea during the cyclone and can trace the path of the cyclone. Secondly, it is a non-intrusive method. Suppose there is a highly rugged terrain or a very difficult topography, and that cannot be, suppose in the Himalayan mountains, we want to see the snow cover changes due to climate change effect of it. So we want to monitor that. It is not possible for us to climb those high hills and monitor the snow path. But by taking remote sensing images, we can actually at a very good temporal resolution, we can capture the time series of those images and can track how much snow cover is changing with time as an effect of global warming and climate change. As well as it is non-intrusive. Suppose there are certain indigenous tribe, the area where they live, we want to keep it pristine, we do not want to intrude there. So in those areas also we can monitor them, their activities without changing the natural system of that area by remote sensing, remote data capture. Secondly, the repetitive nature of the remote sensing data. As I already mentioned, we can do a time series analysis of the changes that are happening at the same area after a certain period of time based on the temporal resolution of the particular satellite. Suppose Landsat, which has a 16-day temporal resolution, so it means it captures data from the same place every 16 days. So if some changes happen between these 16 days, two images 16 days apart will show us the change. So we can do a time series analysis because remote sensing has a repetitive nature of data capture. Third and fourth is the synoptic view and the global and regional coverage. Based on the spatial resolution of the data, we can capture a feature in different scales. Suppose we want to locate our house, we can locate that if the spatial resolution of the remote sensing image is very good. We can capture the neighborhood, we can capture our state, our nation, depending on the scales in which the data is coming. And last but not the least, we can see and obtain information in portions where humans cannot see. As we have already discussed that a part of the radiation is absorbed by the objects. That is later emitted, but that emitted energy falls in the thermal spectrum of the electromagnetic radiation, and the thermal rays cannot be actually sensed by human eye. But when we see a remote sensing satellite capturing the thermal bands, we can easily find out the temperature emitted by the object. So those information can be using different sensors. That information can be seen in different bands of energy. For example, suppose this is the picture of the same area. We can see in band 1, 2, 3 and 4, the water bodies are captured very well in band 4, but the same water bodies could not be captured in other bands. So depending on the feature we want to capture, we can use different bands in remote sensing based on its spectral resolution, and we can outline them very well. Thank you.
পুরোটা হয়েছে তো এইটা তো না এইটা